welcome everyone. Um, I think we are ready to go. Everyone is sitting. So let me start with a small story. Because, well, it's always interesting to start with a story, and I'm gonna keep it very light because it's almost lunchtime. Everyone wants to get a bit of relaxing time now and then have some lunch. So once upon a time, someone was asked to develop a very secure application, and you want to build a secure Java application, you go to start.spring.io. I think Josh usually claps, but I'm not going to do that. Or if you are a Quarkus guy, you just go to code.quarkus.io, and then you bootstrap an application. You do your Scrum thing, you do the story points, you do the sprints, you do the retrospective, and during the sprints, there will be a task in the board which is make the application secure, because as always, security is always seen, most of the times is seen as an afterthought. And then when you are asked to do this, you just go on GitHub and you enable Dependabot to find all those pesky dependencies with CVEs, or you use another tool like Sneak or any other tools out there that do this. And for every CVE that gets marked, you just update the dependency and you're done. I personally believe that this kind of story is quite boring, and it's a bit hypocrite, because to me, I think you are just assuming that security only happens on someone else's code, because you only update your dependencies and you're safe. But security is not about this. Security is about understanding the whole picture, getting to know what's going on. And let me introduce myself now. So, my name is Paulo Lopez. I am a senior security engineer at Spotify, and my squad focuses on application security, and we've been using threat modeling for a long time with success. And I would like to tell you more about this story. I'm also an open source developer. Well, I've been a long time committer for the Eclipse Vertex project. Maybe you have heard of it, maybe you didn't. If you are using Quarkus, anyone who uses Quarkus? Yeah? So probably you are almost 100% of guarantee that you're running some code that I wrote in the past. But that's enough about me. Well, I started the story about doing a bit of ranting on CVEs. I do have some history on CVEs. I've reported at least 3 CVs that if you search for those ones, will find my name there. Medium, high. And I also caused some. So I've been on both sides. That one on the right side, sorry, my bad. I did a big refactoring, and I forgot to check one edge case, which happens to allow people to get access to the file system when they shouldn't, which is kind of bad. So, threat modeling. So I was doing a bit of a tangent, and let's focus. Threat modeling. Threat modeling is a structured activity for identifying and managing threats. Without it, all your software security defenses are just random guesses. So threat modeling is a technique that answers these 4 questions. What are we working on? What can go wrong? What are we going to do about it? And finally, did we do a good job? The nature of these questions is quite broad, and this means that we can do threat modeling during all the phases of software development. We can do it during our architecture phase, during our prototype phase, development phase, testing. And this means that this framework, and I keep saying framework because I don't want to say it's very strict and rigorous. It's very flexible, as you can see from the questions. Is a way to think of security not as an afterthought. It's something you can just do during the whole life cycle of your development. So the first question of thread modeling, like I said, is what are we working on? And we need to see the big picture, we need to discuss with the team, and we need a picture. So we can draw one, like in this example, we draw a picture of what we're working on, and the picture it's very interesting because a picture can always evolve and change, you can update it. So it's something that everyone can just point to and debate. Well, the best place to draw a picture if you are working in the office, like some of us do at Spotify, is to draw the picture on a whiteboard. And a whiteboard is a place for collaboration. Anyone can add, edit, adjust, erase, do whatever. By the way, this is not an official photo of Spotify. I just downloaded it from the OWASP website. And there was an intention there because if you were paying attention, if you take pictures and you share them online, probably you shouldn't share sensitive information. Like even though OWASP does mistakes, they had like the Wi-Fi password and the password and whatever on the original picture. Sorry for the tangent. So the idea of a picture is that you share an idea. So we need to keep it simple. I'm not going to ask people to go back to the UML, because does anyone here like UML or want to go to that way? Probably not. The idea is just to keep things simple. And to keep it simple, we only have like 4 kind of shapes here. We use rectangles for actors. An example would be a browser or a user. We use a circle for a process, so it is a web application, it is a background worker process that does something. And we use double dashes for stores, like a config file, a database, a worker config file for that specific. Oh, I missed a dash on the message queue where we keep data. And we use arrows to signify message exchanges and the direction of the messages. So in this specific example, this is a theoretical example. Let's imagine, because, well, I'm Spotify, we do music. We want to suggest music is similar to what you've been listening. So you have your Spotify app on your browser. Every time you click play, you make an HTTP request to our web application. It goes to the database and serves this is very simplistic. It's not like this, but I'm not supposed to talk about internals of Spotify. So you get the music back, and at the same time, we publish a message to this message queue, which then a background worker process will try to aggregate and do some statistics and distance analysis between genres and artists, and suggest you like, oh, probably you also like to listen to this. So, but if you are in other kind of business, this diagram is quite generic. So just event processing system that would fit this diagram. This is just for illustration purposes, of course. So the second question in thread modeling is, what can go wrong? And lots of things can go wrong. And what could go wrong? Say, for example, that you are using a data center that is built in an area that is below the sea level, and even though you have walls and protections of dunes, it starts to rain a lot, and then there's lots of water that stays there and floods your data center. And that will be terrible for your business, and the application will collapse, of course. So what can go wrong is the key question on thread modeling. And it can be very hard to get right. So if you could scope too wide, like if you worry about floods in data centers, well, I'm not saying that you shouldn't worry about climate change. That's not what I'm trying to say. What I'm saying is that you shouldn't worry of things that were not originally on your diagram. Because in the diagram, even though I just put a picture of a data center, of a flooded data center, By the way, this is DALL-E. It's not real. They were not on the diagram, so you shouldn't focus on that. You should focus on what you already discussed with the team. So it is important to scope properly and find the threats that you can deal with during the project or even during a sprint. And because it's hard to get it right, there is a tool that we use to do this. It's a mnemonic. It's a mnemonic that we use to help you to memorize and answer the question, what can go wrong? So the mnemonic focus on things that could go wrong, and usually they apply to any kind of system. And the mnemonic is STRIDE. STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Failure to look for any of these if you fail to look for those properties in a diagram like this, it's probably a recipe for disaster. So but you also shouldn't assume that STRIDE, like spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, should be a straitjacket. It's not something that you do a checklist, and if it passes the check, then you're done. No, it's a guide. For example, STRIDE might not help you to find out that you are collecting all this information from your users, and there is GDPR out there which says that, well, what you can and what you cannot do with personal data. So STRIDE will not help you that. But doesn't mean that you shouldn't worry about that. Probably need to notify your project manager, scrum master, architect, whatever the business. STRIDE helps you when there is uncertainty and gives you hints where you can look next. So answering the question, what can go wrong, starts with a high-level look at the diagram and continues through finding specific instances of each threat relevant to each box and line in the diagram, because that's where you look. For example, I can imagine that if I use a config file and I write some passwords there in plain text, maybe there could be some information disclosure if the server gets hacked and someone is able to extract the config file. If we're using a message queue, and this message queue, be it Kafka, whatever, if someone else can produce messages that are not conformant to what you are expecting, it could have undesired behavior on your application, and so forth. So you get the idea. Okay. So we've been looking at the diagram. We defined some threats. Now the next step is, what are we going to do about it? And the very first thing we need to do is track this information. You can use this on a whiteboard with stickies, or you can use some digital tool. Like in this example, I'm using a tool from OWASP. If you go to owasp.org, you'll find a tool called the Threat Dragon. It's a very simple HTML page. You can either download it and run it locally, it's self-hosted, or you can use their online version. It's very simplistic, as you see, just a simple whiteboard and just can collect some information. And now you can brainstorm with the team, well, what is the problem, what are the possible mitigations, and you do this for every kind of threat that you just identified. But in the end, you need to track them, and maybe some of the things are bugs, and you use a bug tracking system. Maybe these things are not bugs, but the important aspect here is that you shouldn't discard them. If someone sees a problem, you should still track them, because say that you are discussing something and someone during the session says, well, I don't think this is possible. possible because A, B, or C say, for example, this is not possible because we have authentication in place and you cannot use, an unauthenticated user can do something, then you should probably still track it and either write a test that proves that the threat is not valid, or someone says, well, this is impossible because we have this specific mitigation for this specific issue. Then you write a test to verify that the mitigation actually works for the case that we're discussing. And if we don't track all the information, then we start losing these nodes, and that would be really annoying, because if it happens that you go in production and that actual threat materializes, then you just wasted time here. But there's also the honest I don't know. Like, say that someone makes a suggestion. Say, for example, we're looking at this browser web server application and says, well, what if someone poisons the DNS? Some government-sponsored agency will start faking that our other server is our application instead of being our real application. Well, we don't know, and that's fine. We probably either track it or we just write, like I said, tests and verifications that this is not an issue. So we've been like covering all this possible mitigations. This is like a team effort. It's not something that you do alone. It's something that you do with your team. So we discovered these threats. We filed some bugs. We kind of done threat modeling, right? Well, the answer is not quite. So we need to take a minute and reflect on our fourth question. And it's a very important one. The fourth question is, did we do a good job? It's very important to reflect on this question because we want to do a good job. We want to be able to say, we're done, go to our Scrum board and say, well, task, move to done, we're done. But how do you know that you are not all finished? How can you tell that a Scrum Master that, well, it's actually complete? The answer is, are there clear answers to the questions that frame threat modeling? And those questions are, what are we working on? What can go wrong? And what are we doing about it? If we can have a clear answer to those three questions, then we did a good job, because we are quite confident that if we now put our application in production, it will be better, more secure, and you probably don't need to get so many PagerDuty alerts to fix things in production. So if there are clear actions, there's no more work to be done. And if there are, you need to check for more things. And when you need to check what can go wrong, it's again important to look into the stride. So we need to look into the stride and look into inside the trust boundaries. So what is stride? Like I gave a quick introduction before, but now I'm gonna talk a bit more about why this mnemonic is so important. So stride is a model for identifying computer security threats developed by Prerit Garg and Lauren Kornfelder, if I'm pronouncing their names correct. And they were working at Microsoft in 1999. And they wrote an open letter to the company that started with, and I'm just going to read the beginning of their letter, was like this. The growing use of computer systems to store data critical to businesses, as well as users' personal data, makes them very attractive targets for security attacks. Successful attacks can lead to loss of privacy, disclosure of sensitive data, and disruption of or denial of service. Losses can cost millions of dollars. The Microsoft Security Task Force has defined a security threat model that it recommends all Microsoft product teams to adopt to secure our products for our customers. So this was the time when it was quite normal for Windows to have like a blue screen of that every day. And they've been doing an amazing work, I must say, because all these years, if I look today, I don't remember the last time I saw a blue screen of that. So I think they've been doing quite some work. And they started with STRIDE. So STRIDE, like I said, stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. What is important with STRIDE is that each kind of threat maps to a desired security property that we want to verify and protect. For example, with spoofing, we want to verify authenticity. Tampering, we want to verify integrity on our system. Repudiation, actually, we want to verify that our system is secure against non-repudiation. Information disclosure, we want to verify that the confidentiality property is preserved. Denial of service, we want to make sure that our service is available. Elevation of privilege, we want to verify that authorization is in place. So let's go a bit over all these ones individually. So what is, sorry, what is spoofing? Let me just get some. Now, spoofing is pretending to be something or someone else, typically to gain unauthorized access to systems or information. An example is an attacker creates a fake website that mimics your bank, and then when you go to this website, you're not paying really attention to all the details. You just enter your login password and they start doing credential stuffing. So what can we do about it? Well, like I said, I don't want you guys to make a checklist. These are just ideas. We should work on using strong multi-factor authentication. We can encrypt communication channels to prevent interception of credentials. We can implement secure session management techniques to prevent session hijacking. We can allow only access for known and trusted IP ranges. We can use biometric methods to do authentication, like fingerprinting, passkeys, or facial recognition. It all depends on the problem. These are just ideas. Now, the second property is tampering. And tampering involves malicious modification of data, either in transit or on storage. An example would be an attacker intercepts and modifies data being transmitted between parties. Say, for example, that you're doing a transaction where you're sending 100 euros from one account to another. An attacker could modify this request to, instead of 100, to become 1,000. And that would probably be something that you don't want. So what can we do about it? We can use either checksums, hashes, digital signatures to detect changes in data. We can implement strict action controls to ensure that only authorized people are allowed to do this. We can encrypt data, both at rest and in transit. We can implement audit trails to maintain detailed audit logs and detect and respond to tampering. And thinking about only tampering on storage, we can work with file permissions that set the appropriate permissions to limit who can modify what. So the third property is repudiation. So what is repudiation? Repudiation involves denying that something didn't happen, especially transactions that where proof of action is required. Say, for example, an example would be a user performs, again, a financial transaction and later denies it. I say that I got, someone made a transfer to my bank account, and then I will say that, well, I never got your money, you need to do it again. And we don't want that, so what can we do about it? We can implement like logging. We implement comprehensive logging of all actions and access attempts. We can use techniques like digital signatures to ensure that actions can be traced back to the origin. We can use timestamping on transactions to establish a clear timeline. We can do audit trails. We keep logs that are tamper evident and easy auditable of all the events that happen. And we can ensure that secure communication channels are used to prevent tampering with logs. Again, just some ideas. Fourth, information disclosure. Now, information disclosure is when there is exposure of information to individuals that were not supposed to have access to it. Say, for example, that you are on a web application and you get some information from a different user that it's not yourself, be it like, it could be something very simple like a message, but it can also be like a credit card information. So what can we do about this? Again, we can implement role-based controls, access controls to limit data access and authorization to the users. We can use encryption to encrypt sensitive data that only the right owner can decrypt. We can mask or redact information. Sometimes when we're doing logging, we don't want to print out PII. We can just replace it with a known character or just remove it. We can implement secure coding patterns, like if you are using, if you want to learn more, you can go to the OWASP website and like the typical ones like avoid SQL injections, cross-site scripting, those things. And finally, we can implement some monitoring and alerts for when there are unauthorized access to information. Denial of service. Denial of service is when an attacker aims to make a service unavailable for the rest and by overwhelming with requests. So for example, an attacker will flood a web server with so many requests that it becomes overwhelmed and will crash or becomes too slow to respond. What can we do about this? Well, we can implement rate limiting, we can add a load balancer, we can work with redundancy, so we build a redundancy in the system to avoid the system to be overloaded. We can use DDoS protection services, like, I don't know, Cloudflare, for example. We can work with resource allocation, so we implement resource quotas and controls to limit the impact of these DDoS attacks. Elevation of privilege is the last element from Stride. And elevation of privilege occurs when a user gains access to a resource or operations beyond their assigned levels of permission. So a typical example would be a regular user discovers a vulnerability that allows them to gain admin rights. And when doing this, they can perform actions like deleting data, modifying configurations, or accessing restricted areas of the system. So what can we do about this? So we can work with, during development, we will implement the principle of least privilege, giving users only the access that they need to do a specific task. We can work with access controls by have some rules that we use to allow some operations to be performed. Work with input validation, make sure that there are no ways a user can get into admin by doing SQL injections, cross-site scripting, for example. And also patching and updating, even though I was like making those remarks about updating dependencies, they are still important. There are also ways to avoid these kind of issues. So it's getting a bit late, so I'm gonna try to slow down now and just go into a conclusion. So threat modeling is quite crucial in my opinion because it helps identify, understand, and address potential security threats before they can be exploited. Here are some kind of examples that we can identify with this. We can identify vulnerabilities early. We can improve our security posture because we are now looking at our architecture, our code, our application, and finding all these issues, and we're gonna make them more secure. We're going to prioritize the mitigation efforts. So if you remember, we have this diagram where we put all the stickies with all the issues we found. Some are more likely to be exploited than others, so we can use this to plan our sprints and choose what you're gonna fix first. It's also important to do threat modeling because it also allows you to work with regulatory compliance. You'll notice that maybe you are not allowed to store PII data because of GDPR or any other laws, as an example. It will make you focus on protecting sensitive data. Just because it's on the database doesn't mean that it's safe, as long as more people can access the database. This is just an example. In the end, it will enhance user trust on your application because your application is safer, secure, and if a user can get that feeling that you are putting that effort, that extra effort, probably get more trust by them. And finally, it will reduce the risk. So your applications will be less likely attacked, or at least you are prepared if something happens. So in summary, threat modeling is a proactive approach to security that helps create safer and more resilient systems. So what is important here is that as you think about what you're working on your next project, be sure to ask what can go wrong and what you can do about it. And thank you for your attention, and if there are any questions. If there are any questions, I'll be happy. Yes? So the question is, when do you perform threat modeling? From our experience at Spotify, it's best if we perform this during the design phase. But you'll see that in reality, it happens once there is this initial prototype. There are already a bit of software built that you kind of put on to prove that the project works, that the idea works. At that moment, it's not just a diagram, but it's also the code, so that the developers can also chime in and say, well, actually this message is not as it was designed, but it includes this payload or that specific thing. So our experience shows that this works really well in the beginning, but you can also do it on an existing project. The side effect of doing it on already running project like in a production environment is that you need to implement it twice. So you already implemented something, your development team already deployed and to push to production something, and now we found that maybe there's an issue here. Your development team will need to work again on the project. It consumes more time, so in the end it will be more costly. So the earlier you can begin, the cheaper it gets and the safer you get. Yeah?
Should you keep doing this? I mean, add new service, or change something in your landscape from file system to S3?
Yeah. So the question is it static or should we run, or is it threat modeling a static activity or a dynamic activity? And yes, it is dynamic. What we advise our developer teams to do at Spotify is that we do the threat modeling in the beginning when they are developing, and every time they introduce a new feature or they connect to a different system or do a migration, we do a new assessment. So what we see is that initially we run these sessions in a block of 2 hours, because initially there's lots of ground to cover. But as we keep doing this activity, every time there's a new feature, we focus only on that feature, and a session takes between 30 minutes to 1 hour. We keep it shorter, and this gives you like a really good progress because, yeah, I cannot go like on big details, but we can sometimes just migrating from one programming language to another, that people will assume, well, the messages are still the same, our APIs are still the same. It helps us to do a new evaluation because maybe there are some nuances, some libraries that need to be checked. So it's like a never-ending task. It just, I saw a presentation from, I don't remember. She was working for one big bank in the UK, if I'm not mistaken. And what they were doing is that they introduced thread modeling as the definition of done in Scrum. So every time you introduce a new feature, the feature is only considered complete if at least the whole team spent 15 minutes, 30 minutes thinking about, does this feature, can this feature introduce a new security bug? Does it answer your question? Yeah. Thank you. Anyone else? Then I'll thank you everyone for your time, and I hope you enjoy the rest of the conference.